Hello, welcome to another episode of Maths is Not a Mystery. Today's episode is about prime numbers, all the way from grades 1 to 5. And prime numbers involves the following. You need to be able to identify the prime numbers below 20. You need to express a number as a product of its prime factors. And you need to be able to use power notation if you want to go beyond the foundation stage and go into the edges of the higher paper. Okay, so that's what we're going to be covering today, and we're going to start by taking a look at what a prime number is. All right. A prime number is basically a number that can be divided by just one and itself. What that really means is that a prime number is on two separate times tables. One of those times tables is the 1 times table, and of course everything is on the 1 times table. The other one of those times tables is its own times table. Nothing else, nothing in between. Now that should dispel the first little mystery, because the first question people ask is 1 a prime number? Well, just think what I said. It's got to be on the 1 times table, and it's got to be on its own times table. And they need to be two different times tables. Well, they aren't, are they? The 1 times table is its own times table. So whatever anybody else tells you, 1 is not a prime number. Let's work through and just check on some of the smaller numbers to see which ones are prime, and by the end of that you should have got the idea of how to look for them. So let's start with 2 now. So to check it out, of course it's on the 1 times table and it's on the 2 times table, excuse me, and that's it. It can't possibly be on any other times table. So 2 is a prime number. 3 of course is on the 1 times table. It isn't on the 2 times table because it's not an even number. It's on the 3 times table, and that's it. It's got 2 different times tables, 1 and its own, so it's a prime number. 4 is not going to work, is it? It's on the 1 times table, it's on its own times table, but in between of those two, it's also on the 2 times table because it's an even number. Because of that, because it's got an extra times table, 4 is not a prime number. Now, common sense should be telling you that all the rest of the even numbers can't possibly be prime numbers anymore because they're all on the 2 times table. So we're going to miss those out when we go through the list. Let's look at this one, 5. It's on the 1 times table. It isn't on the 2s, it's not on the 3s, it's not on the 4s, it's on the 5s. It's a prime number. The next odd number is 7, on the 1 times table, not on the 2s or the 3s or the 4s or the 5s or the 6s, but it's on the 7s. So it's a prime number. The next odd number is 9. Now that is on the 1s. It's next on the 3s, and then it's on the 9s. Because it's got that extra times table, it is not a prime number. So don't be led into believing that all the odd numbers are prime numbers, because they aren't. 11 is a prime number, 1 times table, and the next one up is the 11 times table. It's not on any times tables in between. 13 is a prime number. It's on the 1 times, the 13 times, nothing else. 15 isn't. 15 is on the 1s, it's on the 3s, it's on the 5s, and it's on the 15s. So that's more than 2, isn't it? So it's not a prime number. 17 is, 19 is. And the rules say you need to know the numbers up to 20. Well, that's it. So what we're going to be seeing now is our list. And our list of prime numbers to 20 is 2, 3, 5, 7, 11, 13, 17, 19. That's it. So what have we done so far? Well, we know how to figure out what a prime number is. and we know the list of prime numbers between 0 and 20. That is the list. So if you get an exam question that says list all the prime numbers below 20, they are the numbers. Okay, the main part of this video is going to be about that section that said expressing a number as a product of its prime factors. Now, what does that actually mean? Let's take a look. First of all, let's think about what a factor is. A factor is a small number, and you can multiply it by something else to make a bigger number. A little bit like the word factory. You think about a factory, small things go into a factory, they get put together, and out the other end of the factory comes a bigger thing. Factors are the same. So, for example, if we write down the factors of 10, what we do is a nice simple little thing. We think of the numbers that you can multiply together to make 10. Always start logically with 1. 1 times 10 obviously makes 10. Can you multiply anything by 2? 2 times 5 makes 10. 10's not on the 3 times table or the 4 times table. Next time it's on the 5 times table, 5 times 2. That's the same question backwards. When we get to that point where they reverse, that actually means that we have finished our list. And to figure out the list of factors in order, let's just go down the list. The factors of 10 are 1, 2, back up the other side, 5 and 10. So that's what factors are. Now, sometimes the numbers in a factor list will be prime numbers. In this one here, 2 is a prime number and 5 is a prime number. So when we're looking at prime factors of another number, we're looking for its factors and we're looking to find out which ones of those are prime numbers. So let's see how this could work. 12. Let's express 12 as a product of its prime factors. So what we do is we put 12 in a circle or in a box and we create a thing called a factor tree. And you'll see why it's called the factor tree in a minute if you've never seen one. We put 2 little branches coming out of here. And we find 2 numbers that multiply together to make 12. Now, don't use 1 times 12 because you'll see in a moment that that'll leave you with another 12 and we'll just have to carry on doing that forever and ever and ever, and you'll be still doing it when you're 95 years old. So find something else that makes 12. I'm going to do 2 times 6. I find it logical to just start with small numbers if you can. Sometimes it won't be on the 2 times table, but if you can, start with a 2 or a 3 or a 4. Now, what we're going to do with these is we're going to look to see if there's a prime number, and there is. 2 is a prime number, but 6 isn't. So 6 is going to go in a circle. And I'm going to repeat the process now using 6. So just like we did with 12, I'm going to get the number 6 and I'm going to look for two numbers that I can multiply together to make 6. So let's put little branches out there again. And 6 could be 2 times 3. And I'm going to take a look to see whether there's any prime numbers there. Well, 2, of course, is a prime number. 3 is a prime number as well. So that means I've finished. I don't need to put a circle around anything else. I've done. A product means multiply. So what we do is we take the numbers that we ended up with there, 2 times 2 times 3. And that is writing 12 as a product of its prime factors. Each one of these numbers is a factor of 12, and each one of them is a prime number. It's a prime factor. If you do that sum, 2 times 2 makes 4, times that by 3, it makes 12. So that's how you can double check that you've done it right. Do the whole thing in reverse. Now, sometimes there are different ways of approaching this, and I want to show you that you'll always get the same answer. So if I do it again at the side here, and this time I start with a different 2 numbers that could make 12, and if I do 3 times 4, Let's look at the process again. This time 3 is a prime number and 4 isn't. So I'm going to put a circle around 4 and I'm going to look for two numbers that multiply together to make 4, and that's going to be 2 times 2. And they are prime numbers, so there's no more to do. Now look at the numbers that I've got at the end of this. I've got a 3 and a 2 and a 2. And the last time round I had a 2 and a 2 and a 3. They're the same numbers, aren't they? If we were doing this, it would be okay to write it like that, because that's the order that they've come out in. But it's better and more logical if we put it in size order and we go back to this 2 times 2 times 3, put the bigger number at the end. You won't get it wrong if you write it like this. It's just better maths. And if you're going to go further with your maths, it's nice to know that you're constantly training yourself to do something logical. Check it again. The answer 3 times 2 is 6. Times that by 2 is 12. So it's correct again. So that is expressing a number as a product of its prime factor. Product means multiply. Its prime factors are factors of that number, which are also prime numbers, and you do it by creating a factor tree. Now that's going to be at about grade 4. If you wanted to go a step higher and you wanted to go into the edges of the higher paper, grade 5, what they're going to ask you to do is they're going to ask you to express a number as a product of its prime factors using power notation. That's really simple. You're going to do exactly what I've just done here. Exactly the same as what I've just done here. But when you get your answer, 2 times 2 times 3, you're going to change that into 2 squared times 3. Okay, and you can see how I did that, can't you? There were 2 2's. So that little 2 above there means that there were 2 2's. If we had a different answer, if we had something like 2 times 2 times 2 times 3 times 3 times 5, and that could happen on a really big number that we're working the powers out for, then we would count up the 2's. 1, 2, 3. That's 2 to the power 3. Times, count up the 3's. There's 2 of them, so that's 3 squared. And count up the 5's, and there's only 1 of them. And so we write it like that. And that's in power notation. And that's it. That's how you do the power notation. You simply make a factor tree to find all the prime factors, and then you make it a bit shorter to write by creating powers wherever you can. If the same number is there more than once, you count them up, and you write the little number above the little power number that tells you how many there were. I hope that makes sense then. You know how to find prime numbers, you know the prime numbers below 20, and you know how to express a number as a product of its prime factors. And then if you want to be really smart, you know how to do it using power notation. I hope that's dispelled any mysteries. Thank you for watching Maths is Not a Mystery, and I hope to see you again soon. Goodbye.